Hi, everybody. Welcome to JMBE Live for our March 28th, 2025 episode. I am Rachel Horak. I'm staff at ASM Education Department. Today's JMBE Live will be about how students taking introductory biology experience the chemistry content. In a moment, I will put the link to read the open access paper into the chat so that if you haven't read it yet, you can take a look while our speakers are telling us about what they found. Our speakers today will be Claire Meters and Melinda Owens, both of the University of California, San Diego. Moderating the Q&A today will be the JMBE Editor-in-Chief, Stanley Malloy of San Diego State University. So JMBE, or the Journal of Microbiology and Biology Education, is a completely open access journal, meaning that anyone in the entire world can read the JMBE articles free of charge. I love this journal. You can take a look at all the published content, journals.asm.org/journal/JMBE. And with that, let me tell you a little bit how we're going to run our webinar today. If you have a question for our speakers at any time, you can use the Q&A button at the bottom of your Zoom toolbar. You have the option to post anonymously. Just click a little checkbox if you want to do that. And we will have a presentation by our speakers. And then at the end of the presentation, our speakers will have a moderated Q&A with Stanley Malloy. Any problems, you need technical assistance, you can use the chat box to send a message to me as the host for this session. So with that, I'll turn it over to our speakers. Thanks so much for joining us today.
All right, thank you for that lovely introduction, Rachel. I'm Melinda, and I'm here with Claire. And yeah, we really appreciate the opportunity to talk about our paper. Claire? So just to get us in the mood to think about this, just think for a moment, are there topics that elicit anxiety or stress for your students? And how do you manage that? Think about that for a moment. I don't actually think there's a chat, is there, that we can see? Okay, well, we'll just have this as a think. Okay, so we thought about this question a lot, and especially Claire and I both are teaching professors, so we teach a lot. And and we both teach introductory biology. And one of the topics that really comes up in introductory biology that stresses our students out a lot is chemistry. So next slide. And when we looked in the literature, we found that where was this anxiety coming from? Well, chemistry courses do commonly function as weed out courses. So they do that at our university, and there's some studies. So there is a study of foundational intro courses at several institutions. They looked at these and they found the ones with high DFWI rates. So where students fail or withdraw or have lots of incompletes, where a lot of students are having trouble with these topics. And they found that a great many chemistry courses were in this category where they are weeding out lots and lots of students. And this particularly affects the progress of students from historically underserved backgrounds, so they contribute to equity problems. That even students who don't get weeded out, these courses still stress them out quite a bit. And we know that student affect influences learning. So how students feel about the material influences how much they learn. And very importantly, it affects their decisions about whether to persist in STEM. So plenty of students who do perfectly fine and pass these courses still experience a loss of confidence. And that loss of confidence was cited by most of the students who switched out of STEM majors. And citing a loss of confidence was more common for women and students of color. So again, contributing to equity problems in our scientific discipline. Okay. The issue is that as biologists, we know that these chemistry concepts, the ones that are associated with stress and anxiety potentially for our students, are foundational for biology. So one example is this report, Vision and Change. It called for more connections between chemistry and biology. And everybody, biology textbooks, faculty, students consider learning these topics essential for learning the basics of biology and biological molecules. Compounding this problem, so the students coming into our courses have to learn the chemistry-based material, but not all of them receive the same prior chemistry coursework. So at our institution and at many institutions, there's no chemistry prereq for biology. So they're coming in with a wide range of things. And again, we know that students from peer identities, that stands for persons excluded because of their ethnicity or race, so are historically underserved students, they're disproportionately underrepresented in AP STEM courses, including AP chemistry. Why is that? Underfunded schools have less access to AP programs, and also we know that there's racialized tracking into the kinds of gifted and talented programs that lead you to taking AP. So again, the differences in prior coursework also are contributing to equity problems. So that's the big picture. This particular project arose because both Claire and I happen to be part of this anti-racist pedagogy learning community at our university, and we were both teaching this large intro bio course that we're going to talk about. And we realized that kind of our own observations about the difficulty of these chemistry topics and how students felt about them, and the bigger picture about these equity gaps kind of intersected. And so as part of thinking about how to enact kind of anti-racist and more equitable teaching practices, we came to focus on the chemistry material and teaching that well so our students could all be successful in our biology courses. Okay, and so as part of that, we wanted to investigate among our students these questions. First, how does learning the chemistry material affect students' experiences learning biology? We hypothesized that this would cause anxiety, but does it, and does that spread to their experience in our own biology classes? Second, to what extent does prior exposure to chemistry and student background correlate with the student experience learning the chemistry? And to what extent we designed an intervention to help students learn the chemistry material? And to what extent did that influence the students' experience learning chemistry and their experience in our biology courses? Okay, over to you, Claire.
Thanks, Melinda. So as Melinda was saying, we both teach Build 1, our introductory biology class, the cell, and it's a large foundational course. It has between 120, 420 students per course section. We offer 3 to 5 course sections per quarter. It's lower division, so it's one of the first courses in our biology series. And it serves all biology majors, but also pre-health, and is taken by as a gen ed requirement. And importantly, chemistry is not a prerequisite for this class. And so ideally in this class, we are able to teach the chemistry concepts that are necessary for understanding the biology material, and everyone should have an equal opportunity to succeed. In the study, we studied 7 course sections from 4 instructors that taught the course between 2022 to 2023. And for context, out of 1,780 students who responded to our surveys during this time, out of over 2,000 enrolled students, our student demographics included majority women or non-binary students, as seen here in this pie chart. What we're looking at in the middle pie chart is a breakdown of peer and first generation identities, with the most common being non-peer and continuing generation. And then we also had a range of prior chemistry coursework that students were coming in with almost half of students had taken chemistry in college at that college level. But the second most common background was students who had 1 year or less of chemistry in high school. And so students who had not taken AP or had not yet taken chemistry at that college level. We found that there were significant differences in prior chemistry coursework by peer and first generation status. And so what we're looking at here is a stacked bar chart that is disaggregating students' experience with prior chemistry coursework, how much they had alongside their backgrounds. And so focusing in on these green bars, this more than 1 year of chemistry in high school, I want to draw your attention to students from non-peers backgrounds, where these green bars are larger than these green bars in this stacked bar chart. And so this is significant with a chi-square test. We found that a greater proportion of students from peers' identities had less prior chemistry coursework. And so there were differences in amount of chemistry coursework students had before enrolling in our introductory biology class. We asked students, in order to address our research questions, we asked students a survey at the end of the term, and we asked students an optional free response question. To what extent did your experience with chemistry topics in the beginning of the course influence how you felt about yourself as a biologist in the rest of the term? And out of the over 2,000 enrolled students, we had 1,359 students respond to this optional question. And so again, contextualizing this, students were coming in at the beginning of the quarter with a range of prior experience in chemistry, prior differences in amount of coursework, and we asked them to reflect at the end, like, to what extent did your experience influence how you felt? In order to code this open-ended question, we engaged in qualitative coding. We used an inductive process where two coders, two undergraduate co-authors on the paper, worked to independently identify themes and develop an initial code book. They then independently coded 10% of the data set for 2 quarters, calculated coder agreement, discussed and revised the codebook, and went through this process iteratively until they refined a full process of our codes. Once they reached coder agreement on 90% of the responses, of the codes, one person coded the remaining responses. We brought in additional undergraduate coders as time went by and as we collected more data. And each time we brought in different undergraduate coders, they went through this process iteratively to learn how to do the qualitative coding and to reach coder agreement on each of our data sets. And so for our first research question, we explored the ways that learning chemistry affects students' experiences learning biology. Out of this process of qualitative coding emerged 6 different themes. Experience with biology due to chemistry, which was coded in 81% of the responses. Students often talked about struggles with chemistry in the biology course. This came up in 32% of responses. In 18% of responses, students brought up their prior experience with chemistry. And then a few less common but present themes included their attitudes towards chemistry topics, whether or not intervention modules that we'll talk about later on in this webinar did or did not help them, and then also surprised about the chemistry topics. Now let's zoom in on our most common theme. So this was cited by 81% of my students. And I'd like for you to take a moment. Thank you, Rachel, for opening the poll. I'd like for you to make a prediction. What % of students said that they had a worse experience in biology because of learning the chemistry topics in introductory biology? So let's take about 20 seconds, think to ourselves, and then make a vote. Taking a look at the results, yeah, I see a range. And so it looks like most common response is between 20 to 39%, followed by between 0 to 19%. I think some folks may have read our paper, which is exciting. Oops, I went a little bit too far. The answer here is A, between 0 to 19%. So it turns out most students actually did report a better experience in biology. So that our most common code here was better. 49% of students reported this. However, 19% of students reported a worse experience in biology. And 14% of students had responses that talked about it not having, chemistry not having an effect. And so looking at what students said, one student who reported a better experience in biology shared, it made me feel much more confident going into the class because I had a strong background knowledge of what we were talking about. A student who reported a worse experience shared, my initial struggle made me lack confidence and is probably the reason why I found studying for midterm 1 and 2 so daunting. I just had no confidence in the information that I learned. And so while almost half of students reported a better experience, this 20% of students reporting a worse experience was really concerning to us. Our second most common theme was students talking about struggles with chemistry in the biology course. 5% of students reported that they did not struggle with chemistry and biology, with one student sharing, my experience with chemistry topics made some of this material of this course really easy. However, 21% of students reported struggling with this material. Chemistry has always been a topic I struggled in. And when my peers understood a topic quicker than I did, I felt slightly discouraged. Interestingly, 6% of students reported initially struggling, but that their experiences changed over time. So this student shared, it felt very confusing at first, but after getting the practice and strengthening my understanding on chemistry, it felt like I was doing well with applying it to the biology concepts. Our third most common theme was students remarking on their prior experience with chemistry, where 13% of students reported a positive prior experience, one student sharing, I took upper division courses from the nano department prior to this course. Thus, I was well prepared in chemistry. The knowledge helped me to understand the fundamentals of topics quickly. And 3% of students reported a negative prior experience with chemistry, with one student sharing, I did have a background from a chemistry course, but I still feel that I don't have a good foundation of chemistry. And so to sum up our first research question, many students' experiences with learning biology are affected by chemistry in both positive and negative ways. I'm going to turn it over to Melinda to explore our second research question.
Okay, what kinds of factors influence whether students are getting a good or bad experience learning chemistry and learning biology in our courses? All else equal. So what we did here was we ran a logistic regression model. And so we were trying to see how various factors influence the odds of a student saying that they struggled in chemistry. So what we're looking at here is the results of that. So we were looking at specifically the variable struggled in chemistry, and the important numbers to focus on here are in the column, the odds ratio. So for what that means is that compared to our reference student, which are kind of those with historically the most advantage. So like continuing generation, non-peer man that has taken college level chemistry, we're comparing everything against that. So compared on average, compared to that person, now we're looking at the first generation peer, people who are first generations or peers are, and peers, I should say, are 2.43 times as likely. So they're more likely by a factor of 2.4 to say that they struggled with chemistry. And women were also more likely to report that they struggled in chemistry, 1.8 times more likely. We also found, and you might, this isn't necessarily a surprise, that people who had less backgrounds in chemistry also were more likely to report struggling with chemistry. If you had less than 1 year of high school chemistry or no prior chemistry, you were about 2.2 or 2.5 times as likely to say that you struggled in chemistry. Okay. So why does that matter? Well, it matters because struggling with chemistry seems to correlate very strongly to whether you had a negative experience in our biology course because of the chemistry. So there were 284 responses that mentioned both the experience with biology theme and the struggle with chemistry theme. So we were able to see how those themes interrelated. So what we're going to show you, we're going to step through this figure. We're going to show you the percent of students who had a better experience, no experience, or worse experience by whether they said they struggled in chemistry. Okay, next. So we see here that of the students who did say that they struggled, the vast majority of them were in this red bar. So they said they struggled, and they said they had a worse experience with biology because of that. Next. On the other hand, if you said that your experience with your struggle with chemistry changed, like initially it was hard and then it got better, the majority of those students actually said that they had a better experience in biology because of their experience with chemistry. So undergoing that struggle really helped them have a positive experience in our biology courses. And then that's also true of the people who said that they did not struggle with chemistry. Almost all of them said that they had a better experience in biology because of the chemistry. So whether or not you struggled with chemistry is really influencing how those chemistry topics made you feel as a biologist. We wanted to dive into that more and look at kind of other factors that might be influencing whether or not you're more likely to report a worse experience in biology. So we ran another logistic regression model, and here we're looking at the presence or absence of the code worse experience in biology due to chemistry. And as you can see at the very bottom of this, if you said that you struggled with chemistry, you were almost 8 times as likely to report worse experiences in biology because of that. There were also other factors that independently predicted that. So if you had negative prior experiences with chemistry, you were 4 times as likely. And then also your level of chemistry preparation. If you had no prior chemistry, or if you had just high school chemistry 1 year or less, you were also more likely. Interestingly, we also found that women or non-binary students were also a little bit more likely to report worse experiences in biology because of that. But overall, the biggest factor here is the struggle with chemistry. So students struggling through that are really affecting them. Okay, so overall, students who struggled with chemistry were significantly more likely to say that they had a worse experience in biology. I think I'll do the next part too. Okay, so to what extent does using a chemistry intervention? So we designed a intervention, these modules, to see whether that affected students' experience, well, to see whether it affected whether they learned chemistry and also their experience learning the chemistry. So these were supplemental modules that addressed different chemistry topics like chemical structure, bonds, polarity. And so what we did here is that we had a pre-assessment, we had a chemistry post-assessment, and then we made optional modules with kind of explainer videos and practice problems. Okay. And many students used these modules. They didn't have to, they were all optional, but many of them did. They got lots of feedback on which modules to use based on their pre-quiz. The videos had worked examples and guided notes, and there were additional practice problems that students could use. And then we followed it up with this chemistry post quiz where students had to get mastery. They had to get 90% to get full credit, but they had multiple attempts. There were isomorphic questions, so they weren't always just getting the same questions, but this was kind of prompting them to achieve mastery. And what we found is that students did increase in their understanding of chemistry concepts over time. So the light blue here is their first attempt at the post-quiz, and the dark blue is their highest attempt at the post-quiz. And the different bars here are the different instructors teaching in different quarters. And so we see that in every case with every instructor, the students are improving in their chemistry knowledge over time. We also did some further analyses on their midterm scores, their midterm 1 scores, and we found that students who use these modules experience gains in exam performance. So it seems that the students, by and large, and you can see here, most of them are hitting that 90% or more on this post-quiz. So the students are definitely learning chemistry, and it's helping them on their exams as well. So given that overall the students are learning this chemistry, what do you think? Were students who use the modules more likely or less likely, or maybe to say that they struggled with chemistry? What do you think? Go ahead and answer the poll. All right. Thank you for that. So it seems that most folks overall, over half the folks, thought that if students use the modules, they were either slightly less likely or half as likely to say that they struggled. And that makes sense, right? Because if you use these modules and it helped you learn chemistry, then maybe you won't feel as much that you're struggling with it. All right, well, what actually happened? So we were very surprised by this. When we ran our logistic regression model, both for the presence of struggling with chemistry and also worse experiences in biology, we did a process of model selection where we found which variables were not significantly contributing to the model, and you're not supposed to include them if that's the case. And we found for both of these logistic regression modules, module usage, so usage of the intervention, was not found to be significant enough to be included in the model. So what that means is that using these optional modules didn't seem to influence whether you felt like you struggled with chemistry, and it didn't seem to influence whether you felt you had a worse experience as a biologist because of learning the chemistry material. So that was really surprising to us, given that these modules did seem to help students learn the chemistry material, but it's not affecting their subjective experience in the course. Okay, so overall, although the chemistry learning modules did increase student chemistry performance, using the modules did not change the likelihood of a student reporting struggling with chemistry or having a worse experience in our biology course.
So to wrap up, just some general tips and recommendations. Our study contributes to the wealth of literature out there that showcases that student affect matters. it is important to measure it as well. That's something, especially in the context of our intervention, we found that we implemented an intervention that did improve learning, but it did not ultimately change student affect. And so this is something where this measurement allowed us to go back to the brainstorming table and think through, again, like we're helping students learn, but students are still reporting struggling. And so this is something that it's independent or maybe related, but less solvable by this intervention. To wrap up, if you're interested in learning more, I know Rachel's going to be shared a link to the paper in the chat, but we've also included a QR code up top here for the JMBE paper. If you're interested in learning more about the intervention, because it did support student learning, we've included a link to our recent CBE paper over here. And then we've created a shareable Canvas course available on Canvas Commons if you use Canvas as a learning management system. If you're interested in downloading our modules that we created for the intervention, because again, while they didn't change affect, they did help with student learning. And I'll go back to this slide in just a moment, but I do want to acknowledge our fantastic team of 4 undergraduate researchers who really were so vital for this project, for conceptualizing it, for helping us design our modules and interventions themselves, and then working to code our data. And so we had a really great team.
I also want to say that 3 of those folks had taken this course in the past, and so that their kind of firsthand experience on the other end was really, really valuable.
Yeah, absolutely. And I will, and with that, we want to thank everyone for listening today. We're happy to take questions, but I'll move back to this QR code slide for any folks who want to take photos or use the QR codes.
Well, thank you very much, Melinda and Claire. That was really fun and interesting and left lots of questions. I'm going to get to the audience questions, but let me start with just a general question from the very beginning of your talk, where you're talking about weed out courses. So chemistry is a strong weed out course, but mathematics is the granddaddy of them all, right? I think about, if you look at the different forms of mathematics, it's something on the order of 40% of the weed out. And a lot of chemistry involves mathematics, right? So my question is part of that weed out that you saw tied to chemistry really the underlying mathematics? But in the examples you gave, it was really structural, it seemed like. So maybe that's not true.
That's an interesting question, because people have shown that there was a study that showed that performance in a traditional chemistry course had a lot more to do with like mathematics knowledge and facility with mathematics than actual chemistry, like than performance on a conceptual chemistry quiz. So you're right that in part of the weed out nature is the reliance on math. I don't think that was necessarily the case in ours, because when we were talking about the chemistry topics in our course, we were not focusing on the mathematical aspects. Like there's no equation balancing or anything like that. It was about topics like bonds and polarity and things like that, but talking about it in a very qualitative way. So it could be that like kind of they get this bad vibe from chemistry in part because of the math, and then it becomes associated with chemistry, and they're bringing that to our biology courses, but it's not like direct math anxiety, we think, in our courses.
Yeah, and I want to build off of that. I saw someone posted in the chat to us early on sharing that a challenge that students face is that some of the topics taught in chemistry are not related to what we need to practice. And I would agree with that. I think that's something that it's one reason why Melinda and I weren't recommending, one outcome of this work for us was not to recommend that students have a prerequisite of chemistry, but rather that we could work to develop modules for our own courses that were directly relevant to the topics that were needed to succeed in our class. And so that was something that we did find was helpful for all students learning. Because I agree, I think that that's something where it could be a combination of experiences and from math, the quantitative side, evoking and eliciting this anxiety, but then also, even if a student has had that class, they may not have actually been taught the emphasis might not have been on, like Melinda was saying, bonds and relevant material for chemistry and biology.
An aside to this is really an aside for the two of you, but I think you mentioned in the paper that this is less of an issue with ecology and evolution partner course to this one. And that really actually surprises me, because I think of ecology and evolution as, especially if you're going to think about fitness or niches, which are core concepts there, it's really very dependent upon an understanding of the kind of the physical chemistry at a basic level, and the mathematics. But it doesn't seem to be an issue there, it sounds like. Is that correct?
I think perhaps at the level that we teach it at Intro Bio, it's perceived as less. Like, yes, of course, like chemistry is underlying all of these things, and it's underlying why we get mutations in DNA, and like it's so and why environments work the way they do. But I think that is buried deeper than the level that we teach it in Intro Bio, whereas like Intro Bio courses, like you start off structured DNA, bonds, atoms, membrane transport. You got to understand hydrophobic, hydrophilic. It's right there in front of you.
And from the beginning, I think in an intro evolution class, you might not be covering fitness on class lecture 1. And so I think that the fact that we dive into all this material right away in the class really sets up student expectations for, as we saw from some of the student quotations, how they were feeling about midterm 1, midterm 2, and long-term in the class.
So I'm going to ask some questions from the audience here. And Karen asked, did you look at the background of the non-responders to see if there was one of the groups was disproportionately represented there?
Non-responders to the open-ended
your initial survey.
Yeah, that's a great question. We did not do that because that would have students needed to opt in to taking our survey, and it had self-report demographic data. So the folks who did not respond to our survey, we didn't have access to their demographic data. We could have looked at the difference between the students who responded to the optional question versus the students who took the survey and didn't. And we haven't done that. So that would be interesting to explore.
Yeah, but there's a great many students that we just don't know anything about because they didn't do the survey at all.
So Karen also made the comment that she often finds students who uses her optional supplemental materials be the ones who need it the least, right?
Yeah, so actually in our other paper, the one in CBE Life Sciences Education, we did address that. So we found that actually the students who scored lower on the pre-quiz were more likely to use the modules. So in this case, it seems that like the students were they didn't have to use the modules, no one had to, but the students who were doing poorly were more likely to like identify like, hey, I need this resource, and we're using it. So actually we were pretty happy about that because I've had that experience the same as Karen in other courses when I've given other kind of extra opportunities. But in this case, something about like, oh, you have to, perhaps it's because it was mastery based, like everyone had to get 90%. Perhaps that was motivating students who needed it to actually use these resources.
Yeah, and each time students received missed a question on one of the post-quiz assessments, they also were directed to the relevant page that had a topic and relevant short 5 to 20 minute student narrated video with practice problems. And so the students could have taken any approach to learning, to mastering the material, but this was, I think, the path of least resistance because it was right there embedded in the questions.
Did the students get credit towards their grade for completing those assignments?
Not the optional practice problems, but they did get credit for the pre and the post quiz. Those were mandatory for students.
And by the way, one other question related to that. Do you tell the students in advance that completing those optional assignments tends to improve the grade of students? Yeah, I think it would be a big enticement.
I mean, at the time we were studying it, so we didn't know.
Yeah.
Okay.
I think in the future, that's something we'll be able to share.
Yeah, absolutely.
All right.
And we have shared the aggregate data with other instructors who have taught the class to showcase that, yes, this intervention did support student learning of the material.
So Emily is facing a problem similar to what you've seen in her classes, and so struggling with the question about requiring majors to take general chemistry first, or what, and the issue of weeding out people who would be biology majors but just don't make it through the chemistry.
Yeah, so there's actually history at our institution. So this course used to have a chemistry prereq, but it was taken away. They removed it to reduce time to degree, and I suspect also because of these weed out problems. And from our experiences here with our modules, right? Our modules were available for 2 weeks, right? Our chemistry mastery post quiz was given in week 2, and we're on the quarter system, so we have 10 weeks total. So this was week 2, so it's just right up front. And so my takeaway from that is that you don't need a whole year of chemistry. You don't even need a quarter of chemistry. You need like 2 weeks of very, very focused stuff because there's a lot they teach in interest chemistry that is just not relevant. And from a anecdotal personal point of view, I find that students who have taken college chemistry, I mean, they do know more chemistry, but they, sorry, they come in with different misconceptions, and I can kind of tell whether people have taken chemistry or not based on the misconceptions they're coming in with. I also want to say that when it comes to the chemistry learning, the students who took, sorry, maybe you can talk about the performance on the pre-quiz. I'm so sorry.
Oh, no worries, Melda. Yeah, so we found that on average, the student grade on our pre-quiz was a 61%. And so all students really needed to brush up on these most relevant topics for chemistry and biology for us. And I think that was one of my biggest takeaways was, again, like Melinda was saying, 2 weeks is sufficient for getting students to that mastery level. Collectively, all of our videos, we chose 6 different topics to focus on. Our videos that were student narrated collectively took about an hour across all the topics. So if a student chose to engage in all of the topics and then the extra practice problems, there were about 3 for each topic. And so conceivably it could be done in probably 3 hours of extra time for studying that material. And so it was something that was very targeted, focused, and seemed sufficient for the learning aspect. But again, for that affect piece, we do think that a lot was because a lot of this, the downside of it being asynchronous, done individually, that might have been where students still felt that they were struggling with the material and didn't have that community aspect to address those affective parts.
I think that leads into a question from Anonymous here.
Yeah.
And the question is, wouldn't it be a better practice to just require everyone to do it because of a stigma? So for example, you might think that people who need to do it might feel like it's adding more work to them, or it's saying that they're a stereotype of not having this quality. And if you required everyone to do it, then it wouldn't have that kind of a stigma.
That's an interesting point, and I really appreciate it. One benefit of doing this asynchronously was that the students didn't know who was doing it or didn't doing it, and we weren't calling out any students who it wasn't framed as a you need this as a remedial support. It was more framed as a this is a study resource. But I agree, and that's one thing that we talked about was maybe in order to prevent additional, like, even though it's a couple hours of extra time, it is still time. And so one thing that we've talked about is maybe requiring students to select one module that they want to use and requiring one module. So it could be them choosing which area they want to brush up on the most. And then at that point, everyone has engaged with at least one of our 6.
Yeah, I also want to reiterate that almost everybody needed at least some practice. Very, very few students, even students who had taken college chemistry courses, scored above 90% on the pre-quiz. So almost everybody could use brushing up with something. And again, the asynchronous nature of it meant that nobody knew who were doing it and who was studying how.
So Ben asked the question, we've talked a lot about chemistry as a prerequisite. What about as a co-requisite?
Yeah, again, I don't think it lines up. Because actually, if you look at our topics, they come from different places in the chemistry curriculum. Some of them are very fundamental, like bonds are very fundamental. But other things like interpreting organic chemistry structures. So I find that it's personally really useful that I can draw a hexagon on the board with some O's in it and have the students kind of understand on a basic level what that means. But that's not taught until OChem. Um, and obviously, I mean, maybe it's not obvious, but like, I think it would be really undesirable to force students to take OChem before they could take intro bio. So having this asynchronous approach where we make our own modules is giving us the flexibility to pick from different aspects of the chemistry curriculum that are most relevant to our biology work. And not have it be tied to another curriculum with different context too. And we also know from the literature that transfer is hard. So knowledge transfer from one domain to another domain is hard. And also chemists are talking about different things. So when we talk about biology, we're always talking about stuff happening in water, and that affects the relative strengths, for example, of ionic bonds and covalent bonds. So the students who have taken chemistry come in and they're like, ionic bonds are super strong. And we're like, actually. So I think it's just different purposes. And so we really appreciate the flexibility that these modules have given us as instructors.
So Karen asked the question of how can you encourage engagement from the students who need more of a boost? In other words, instead of just providing it and saying, oh, this is something that would be valuable, is there a way of really encouraging it? Not only that they do it, but that they engage. And that's tied to another question that you raised in your talk, and that is, how can you make it and make them have a better feeling about chemistry? And can the modules achieve that goal instead of just knowledge, also a feeling of knowledge?
Yeah, that's a really great question. I will say we did get more engagement from students who did seem to need more of that boost, where we found that, again, the students who were engaging in these modules tended to be students who had received lower scores on the pre-quiz, but they also tended to, because this was delivered on our course learning management system, we were able to look at the number of attempts that folks did on our post-quiz. And we found that the students who had received lower scores tended to use one additional attempt to reach mastery. So they were, the students who did engage were engaging, they were the students who needed it and were using it as intended. To Karen's point about how do we reach the students who weren't engaging in it, I think that's a really great question. We did look at at an instructor level. We had 4 different instructors in this study, and one instructor did have higher engagement with the modules than others. And I suspect that that's something about the way that they were encouraged, students were reminded to use these, encouraged, which again, may not have influenced affect because this was happening individually, but it influenced engagement and use of those modules.
So Elizabeth asked the question of that ties again to the attitude after doing the modules, right? And she was wondering whether the people who did the modules and were confident before they went in other words, had a good attitude, if whether that just kind of made the change in attitude not as obvious, because they would say, oh, it didn't change my attitude because they went in with a good attitude, right?
That could be. This was only asked at the end of the quarter, so we only asked once. So I think it would be very interesting to ask in the beginning versus the end. But yeah, I think that's a future study.
One of the other questions comes back to a way that biology used to be taught, still is in some places, and that is, has your university considered offering 2 different first-year courses, one for non-majors and one for majors? With the underlying presumption is that non-majors might be able to have much of the content without the chemistry.
Yeah, that's a great question. We actually do have a faculty member who will be teaching a non-majors biology class, I believe, this spring quarter, but it hasn't been offered for a while, at least since I've been here, I think. So it's a new.
It has, but
Okay.
very few students take it for whatever reason. I think this is a university specific thing where it's not, I don't know to what level it's pitched. But yeah, a lot of non-majors take our majors bio course, choose to take our majors bio courses for whatever reason. And so we have to teach them.
There are a lot of universities where 90% of the students who are coming into biology think that they're going to end up becoming MDs at the end. And so, of course, they want to take that more rigorous course, which is a bit of a challenge. And so this raises the question of, you don't want to lose people from biology because of some unreasonable constraint. But maybe some people in the process of going through biology just naturally, maybe it's a learning process that they say, oh, it's just not for me, really. And if I was to answer my own question here, I would say that would be fine as long as it wasn't a disproportionate burden on one particular group. Is that fair?
Yeah, and I think ideally it would be because someone has made that decision because of interest, not because they're worried that they, like, quote unquote, can't handle a topic.
We have a lot more questions, which I think says a lot about how important this issue is, but we are running out of time. And so I just like to say, I think this is an important issue. Many years ago, 20 years ago, when I was at the University of Illinois, I had the ability to develop a new first-year biology course that came before chemistry. And that was because chemistry got rid of all our biology majors. So that was a long time ago, and you see the problem still exists. And so I think that the follow-up that you'll do will be really valuable for all of us in terms of thinking about ways to solve this long-term issue that really influences our access to people.
I know we're running short of time. I just want to share, like, anecdotally, I've heard from students who took chemistry after taking our class and talk about how the preparation has helped them for the future. So I do think, like, it is one way of kind of inoculating for students who have like gain a little bit of confidence going into these other courses. It shows them, it can show them that like they have the tools to learn in those other courses.
I've also heard the converse. Students say, like, I totally did not understand this in chemistry class, and I didn't know why I was learning it. It felt like hazing. But I'm coming to this class and now I'm getting it. And I'm seeing why it's important. So that I think makes I mean, it makes me feel good, but it also shows the importance of like kind of meeting people where they're at.
Many of us learners like to see relevance if we're going to invest the effort in learning. So, all right. Well, so thank you very much. And I'd like to ask Rachel to come back for final comments, if she hasn't dropped off because of Wi-Fi. Great.
Hi. Okay. Thank you so much for telling us more about your paper. You can see through the Q&A that people were really excited to learn more and to think about how this could apply in their own introductory biology classes. Into the chat, I am putting the link to the YouTube playlist for JMBE Live. You can see that we have a collection of over 30 recordings from JMBE Live since we started in 2020, and you can go back and watch them all if you choose. The recording for this webinar will be available probably within a week or so. Coming up, we have one more JMBE Live for our spring 2025 series, and that will be Friday, May 2nd at 1 p.m. Eastern Time, and the topic will be Teaching with TED, a curated set of TED Talks and discussion prompts for microbiology and cellular biology courses. The speakers will be Diane Morgan and Elaine Hotsey from University of Kansas, and I think that we're going to really enjoy that. The registration will be free, as all JMBE Lives are free for anybody who wants to attend. Watch for emails, watch for social media posts about this for your free registration. So with that, thank you, speakers. Thank you, Stanley, for joining us, and we'll see you at a future JMBE Live event.
Thank you.
Thank you for having us and for participating.